Good morning. My name is Subhash Chandra Bose. Now I am giving the demo in physics subject. The concept is vertical circular motion with variable speed. Let me write that heading on the board. Vertical circular motion So how you need to understand this concept? Let us take a body. Let the mass of the body is m. This body is tied to one end of the string like this. It is tied. Let the length of the string is L. Now on the second end, by fixing it, you can rotate this connected body in vertical circular path. So by wheeling this body of mass m, by fixing it one end of length L, we can wheel it in vertical circular motion. While it is rotating in vertical circular motion, let us examine the points. This is the lowest position. Let us say this is the highest position. Let us say this is a position with some angle made with the center. Let the velocity at the lowest position, let us say some v1. At the velocity at highest position, let us say v2. The velocity at any angular position, let us say some v theta. Now we need to find out the velocity of the body which is connected at any point. Velocity of the body at any point in vertical circular motion. Let us say this is symbolized with v theta. To find this one, we need to apply the law of conservation of energy. So according to law of conservation of energy, let us take the position names. That the lowest position is A, this position is P. So we can say that total energy at P can be written as total energy at A. Total energy at P is defined as the sum of kinetic energy plus potential energy, that is equals to kinetic energy at A plus potential energy at A. So we can write Kp is equals to Ka plus Ua minus Up. So let me solve this one. Let me rewrite the diagram again. So in such cases, we can understand that if suppose if this is the circular path in vertical circular motion, this is the center, here is the radius r, the length of the string will become radius of the circular path. This is position A and here it is position P. So now we can write Kp can be written as Ka minus of Up minus Ua, where Up is potential energy at point P, Ua is potential energy at point A. This Up minus Ua can be written as minus mgh. While the particle is transferred from A to P along the circular track or curved path, it will be at a height h from the lowest position. Let us say this height is h. If this part is h and this entire part is r, then this will be equals to r minus h. Let this angle is theta. So let us say this is APP dash or OP some P dash from triangle OPP dash. We can write cos theta is equals to adjacent side r minus h by hypotenuse r. By simplifying this, we can write by simplifying this equation, we can write as Kp is equals to Ka minus mg into, where here h equals to 1 minus h by r equals to cos theta. So h by r is equals to 1 minus cos theta. H is equals to r into 1 minus cos theta. Kinetic energy at point P can be written as half mv theta square is equals to half mv1 square minus of mgr of 1 minus cos theta. So while you are finding the velocity of a body which is in vertical circular motion, it is completely angular dependent. Here v theta is velocity at any point. Velocity at any point. So we need to find out the velocities at lowest position, highest position, as well as other angular positions. So we'll take that equation. So by taking this, half mv theta square is equals to half mv1 square minus mgr of 1 minus cos theta. In the entire equation, m is taken as common. So by taking m as common, you can cancel out. So we can write v theta square is equals to v1 square minus 2gr of 1 minus cos theta. If suppose this is the vertical circular path, here the angle at initial point the angle is some 0 degrees, here the angle is some 90 degrees, at highest position the angle let it be 180 degrees. So we can write velocity at highest point vh square equals to v at lowest square minus 2gr of 1 minus cos 180 degrees. Where cos 180 is minus 1, 1 minus of minus 1, 2, it is 4gr. Therefore, vh square is equals to vl square minus 4gr. So the difference between squares of the velocities between lowest position to the highest position is equals to 4gr. In other words, we can write vl as v1 square minus vh as v2. Then also this equation can be written as 4gr. So whenever a body is revolving in vertical circular motion, from position to position, that is made an angle with respect to the center of the vertical circular path, its velocity is going to change. So here it proves that the square of the velocity differences between lowest position to highest position is equals to 4gr. Not only the velocity, there is a chance of change in tensional force also from position to position along the same vertical circular path. Now we will try to find out the tensional force also. If suppose the same circular path can be taken, so here is the center of the circle, here is the center of the circle, this is the lowest position, here is the body of mass m, at this position its tensional force is equals to mg. It came to some other point which makes an angle theta with the center of the circular path. At this position, its tensional force can be written as the entire weight of the body is equals to mg, and this mg can be resolved into two components. One is along the line, here it makes an angle theta, it is mg cos theta, and the perpendicular one which is in the tangential direction, mg sin theta. So on to the center, towards the center, T theta is the tensional force. At the lowest position the tensional force, let us write TL. At the highest position the tensional force is TH. So tensional force at any point can be represented with T theta. Now we are in the business to find out the equation for this T theta. If you observe this section at point P or some other angular position, T theta is towards the center, mg cos theta is out towards the center. So the resultant of T theta and mg cos theta gives the necessity centripetal force for the circular motion or for the revolving path. So therefore we can write T theta minus mg cos theta, which is equals to mv theta square by r. Therefore T theta minus mv theta square by r, which is equals to mg cos theta. From this we can write tensional force at any point T theta is equals to mg cos theta plus mv theta square by r. At lowest position, let us suppose theta can be written as 0 degrees. At lowest position theta is equal to 0. By substituting cos 0 is 1. So TL can be written as mv1 square by r plus mg. At lowest position its tensional force is always maximum. So let me do that calculation again. So we can write TL equals to nothing but T max is equals to m v1 square by r plus mg. If the same body went to the highest position in the circular motion, let us say this point, so from the lowest position to the highest position the angle difference is 180 degrees. It will phase out by 180 degrees. So at highest position position, let us say TH is equals to, means tensional force at highest position is equals to, by substituting theta is equals to 180 degrees, therefore mv2 square by r cos 180 is minus 1, which is nothing but minus mg, which is actually called as T minimum. So when a body is under vertical circular path with varying speed, its tensional force also varies from position to position during the path. So at the lowest position, its tensional force is maximum. I have written this here also. At highest position, its tensional force is minimum. So let me write how much is the difference between the tensional force from maximum to minimum, or lowest position to highest positions. So T max minus T min, which is nothing but tension at lowest point minus tension at highest point, which is equals to T max is mv1 square by r plus mg minus T minimum equals to mv2 square by r minus of minus plus mg. So we can take mg plus mg, 2mg, plus m by r as common, v1 square minus v2 square. Based on the differences in the velocities from position to position, v1 square minus v2 square can be written as 4gr. Therefore 2mg plus m by r into 4gr, where r and r gets cancelled, 4mg plus 2mg, which is nothing but 6mg. So the difference in the tensional force from lowest position to highest position of a body when it is under vertical circular motion is 6 times of its weight. So TL minus TH, or T max minus T minimum, is equal to 6 mg, where V1 square minus V2 square is equals to 4gr. Now we will try to find out the velocities at lowest and highest positions, even tensional forces in the lowest and highest positions, in terms of a common integer. So here is the vertical circular motion. The body is under vertical circular motion. Let us say it is V2, velocity at highest position. Let us write this one as root over ngr. So according to the given calculations, V1 square minus V2 square is equals to 4gr. Therefore V1 square is equals to 4gr plus V2 square means ngr. Therefore V1 square equals to n plus 4 of gr. Therefore V1 can be written as root over n plus 4 of gr. So at the lowest position, V1 can be root over n plus 4 into gr. So how much is the ratio of the speeds from lowest position to highest position when a body is revolving in vertical circular motion? V1 by V2 can be written as so the ratio of velocities from lowest position to highest position, V1 by V2 can be written as root over, where gr and gr gets cancelled, we can write root over n plus 4 by n. In the same way, you can find out the ratio of the tensional forces also from lowest position to highest position. So we can say tension at the lowest position is mv1 square by r plus mg, where v1 square is equals to root over n plus 4 gr whole square. So where r and r gets cancelled, therefore tension at lowest position is equals to m by r into n plus 4 into gr plus mg. Where r and r gets cancelled, taking mg as common, n plus 4 into 1 plus 1, therefore it is n plus 5 into mg. So tension at lowest position will be n plus 5 into mg. Whereas tension at highest position, mv2 square by r in minus mg, so you will get n minus 1 of mg. So the ratio of the tensional forces is root over n plus 1 by n minus 1. In such a way, you can find out the ratio of the velocities during the vertical circular motion and tensional forces in the vertical circular motion. Not only these conditions, there is condition for looping, condition for tracing out, and many other cases are there which are exclusively important for different competitive fields like JEE and NEET. Thank you very much.